Welcome, Maths with EJD. In this video, we're still talking about statistics, and here the focus is on graphical representation of descriptive statistics. We've been talking about descriptive statistics all along, uh, focusing on measures like dispersion or location, um, position, measures like shape, and of course, variability or dispersion. All right. So here we just want to demonstrate some of these things in graphical format. So I'm doing it in a Jupyter Notebook environment using Python codes. So I'm not worried about the codes, but you can follow along and just see how these things work. Okay. So of course, graphical representation of descriptive statistics is a crucial aspect of data analysis because it provides insights into the data, making it easier to understand patterns, trends, and distribution. So, when you see a data set, it may be difficult to actually make sense of it sometimes. Of course, there are some data sets that you can actually, understand by just looking at them. But then when things get really, really large, it may be difficult to get patterns. So graphical representations can make those things make sense. Okay. Different tools are employed in graphically representing descriptive statistics. And the first tool we are looking at will be the bar charts. So bar charts are used to represent categorical data with rectangular bars. So the length of each bar corresponds to the value it represents. For example, imagine a survey of favorite fruits among students might show categories like apples, bananas, cherries, and grapes. Each fruit would have a bar representing the number of students who selected it. This visual allows for easy comparison between different categories. So you see here we have 25 students like apples, 40 like bananas, 30 like cherries, and 15 like grapes. So we want to show how this looks like on a plot, on a bar graph. So you see that. So you have the bars are as long as the number of students that like them. For instance, the mode is for bananas because the highest number of students like bananas, followed by cherries, followed by apples, and then grapes like that. So this is how bar charts look like. Okay. Of course, if you have some data, you can just use this simple Python code and just extend it to suit what you would like to do. Okay. Of course, this can actually be done manually, right? You just need to do the x-axis, the fruits, and then the y-axis, you have the numbers, and you can just do, some sketching. So it's actually possible. I think I did something like this for histograms in a previous video. I think that must have been talking about maybe percentile or something like that. So let's talk about histograms. Histograms are actually like bar charts, except that there are no spaces. So you can see spaces in between bar charts, right? But for histograms, there are no spaces in between. So histograms display the distribution of a continuous variable by dividing it into intervals or bins and counting the frequency of data points in each bin. For instance, if you have data on the ages of participants in a study, you might create a histogram with age ranges like 0 to 10, 11 to 20, etc. on the x-axis and the number of participants in each age range on the y-axis. So let's see. This would actually illustrate the distribution of ages clearly. So let's see what this brings. So imagine this now. Okay, we just generated numbers randomly, okay? And then we have all the bins. So the first bar is 0 to 10, 11 to 20, the second one, and so on and so forth. So you can see that the mode in this case is something around 60, the bar for like 60 to what are we following? Like 61 to 70 or something like that. So that's what histograms look like. They can actually be made manually. All you just need to do is not put spaces in between. Of course, when we talked about measures of shape, like kurtosis and skewness, histograms are really very useful to see how data is distributed. Okay. Then, of course, there's this very useful tool called box plots, or you can sometimes call them box and whisker plots. Box plots summarize data based on five number summaries. So it shows you the minimum value of a data set. It shows you the first quartile. That the first quartile corresponds with the 25th percentile. It shows the median, which is like the 50th percentile. It shows the third quartile, which is the 75th percentile, and it also shows the maximum. Then box plots highlight the spread and identify outliers. So you can see outliers when they are available in a box plot. For instance, if you're in a study comparing test scores of students from different schools, a box plot can show the median score, the interquartile range, and any outliers. This allows for quick visual comparison of score distributions between schools. So if you want to compare schools, say you have school A, school B, school C, and you want now we are generating scores randomly so we can visualize differently. So if I run this now, it shows us it shows us three box plots. So you can see that for school A now, the minimum score for school C is something a bit above 20, and the maximum score is close to 120 and all that. But the average minimum score, I mean the average median score is the highest average median score. The highest median score actually is for school B. So you can see the median score is like this. And then the distribution for school B is also a bit higher. The interquartile range is a bit higher than for the others. So the line here, this is the median. This is the median in the centers. This is the minimum score. So you can see that school B seems to perform the best because their minimum score is higher than every other minimum score for every other school, right? Just like their median. So this is the lowest value, the maximum value. This is lower quartile, which is the 25th percentile. This line is the upper quartile, and the line in between is the median, like that. So if there are outliers, you can see them as dots outside. Since these scores are generated randomly, I can run this again, and then the shapes can shift. So if I run this again, so you can see these dots now show that there are some people who score unusually below the minimum score. And this, so when you see these dots, they actually talk about outliers. So school B is still doing well based on this. School C has a couple of outliers. So since the scores are randomly generated, I can do this again, and then the shape continues to shift. Okay, so that's about box plot. They are really useful when you want to understand data distributions. And then you have pie charts. Pie charts, just like bar chart, they are really common. So it's just like you taking a circle and dividing them into sectors based on the frequency of the things you're considering. So for pie charts, right? Pie charts represent categorical data as slices of a pie, okay? Showing the proportion of each category relative to the whole. You can also consider it as slices of a pizza, okay? So example, a pie chart depicting the market share of different smartphone brands could show Apple, Samsung, Google, and others as slices. So each slice represents the percentage of the total market share that each brand holds. So imagine that we want to look at market share of smartphones. So the smartphones are Apple, Samsung, Google, and others. So you have for Apple, you have 40, Samsung 30, Google 20, others 10. And then talking about the colors, you have gold, light blue, light coral, and light sky blue for the pie chart now. And then you can see what that looks like. So you see now, the highest market share is owned by Apple. So Apple owns 40% of the market share, followed by Google with 20, followed by Samsung, sorry, with 30%, and Google 20%, and others 10%. So that's actually, so with this now you can see how, if you all you just want to see is who is doing better, you want to see the ranking of how well the brands are doing. So a pie chart can quickly show you that also. Then we also have scatter plots. Now, when things are getting a bit mathematical, right? You want to see things like correlation. We've done correlation and covariance and correlation. So if you want to see correlation, scatter plots are really useful in that regard. So scatter plots are used to show the relationship between two continuous variables. Each point represents an observation in the data set. So for instance, a scatter plot comparing hours studied against exam scores can help visualize any correlation between study time and performance. If the points show a clear upward trend, it indicates a positive correlation. So for positive correlation, right, you have a straight line that is rising from left to right. But if it is decreasing, so you have a straight line that is or you have something like a shape that is decreasing from left to right. Okay, so you're going to see this kind of thing here. So again, the hours of study and the exam scores are also they are going to be randomly generated. So from this now, it clearly shows that now if you look at this, you can easily draw a straight line called the line of best fit across this red line. So you see it's rising from left to right. That means that the higher the number of hours studied, the higher the score a student gets. So let me see if you can get other possibilities. Okay, it's still showing the same trend. Let me try again. Same trend. Try again. Same trend. Okay, always the same trend with little variations, right? But it's showing the same trend all the way. Now, the interesting thing about this is it's more like you also want to see the correlation between the performance of students in maybe physics and mathematics. So you want to see that you want to say, oh, is if a student scores high in math, are they also likely to score high in physics? So if you get those scores, you can easily just make a simple graph and just mark the points and say, okay, student A scores 72 in physics and then 85 in mathematics. So you mark that point and then you do it for all the points. And then from there, you can see a scatter plot. So that can already show you the trend to see that, okay, maybe when the student is very good at maths, they are most likely also good at physics. You can do that to see, okay, if a student is good at physics, are they also good at economics? You can do those pairings to see how if there are correlations like that. Okay. Then, of course, very close to the idea uh of scatter plots would be line graphs. Okay, line graphs are used to display data points over time. They connect individual data points with lines showing trends. So, example, a line graph showing the monthly sales of a product over a year can help visualize trends such as seasonal fluctuations in sales. Each point represents the sales for a specific month, and the line connects these points to show overall performance over time. For instance, if you have monthly sales in January, 200 sales, February, 250, and so on and so forth. And then in December, it's like 1,000. So you see that from January to December, you have increasing sales, even from the data alone, but the graphics gives you a better picture. Now you can see that normally, if you draw this line straight, there's a steep normally, if you draw this straight line, the line should have gone straight. But it looks like, of course, though the sales are increasing, but it is increasing at a reducing rate. I don't know if you understand that. It's increasing overall, right? Like if you draw this first point with the last point, you see the line is steeper than this, but then it looks like fine, it is increasing, but it is slowing down around July before it picks up again. So those are some kind of things you can find in a line graph. All right. Then we also have heat maps that are really useful. Heat maps use color to represent values in a matrix format. They are useful for visualizing data density or the intensity of certain values. Example, in a heat map showing website traffic by hour and day of the week, darker colors might indicate higher traffic, allowing businesses to identify peak usage times. So for instance, you want to see so website traffic, like you have a website and you want to monitor the analytics of the website, like at what hour of the day or day of the week do people really visit your website? So in case you have something to market to them, you can target that particular point in time to do your marketing. So you can see something like this now. So say day of the week, that's 0 to 6. Of course, this should be 0, 1, 2, 3, 7 days of the week, right? Because counting in Python starts from 0. That's why you have that this like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, or something. And then you have hours of the day, like from 12 midnight to 23 o'clock, like very close to 12, the following day, 24-hour period. Now, from what you can see, if you look at this bar now, this is the color map that shows you what the colors indicate. So the darker the color is, the higher the traffic. So you can see there's a lot of traffic on Sundays around 2 p.m. I mean, yeah, around 2 a.m. rather, then you can jump here and see okay, you have a lot of traffic around 5 p.m. on Wednesdays and so on and so forth. So you can see those dense as the darker the color, the higher the traffic around that time. So you can now watch out for these dark areas and see when to target maybe you have some advertorials or you have some campaign to embark on. And of course, the light sites, you may have to relax around those times since there's not so much traffic around those times. So heat maps can really be helpful like that. Heat maps also can help us with correlation. Like I talked about the scores of students in both physics and mathematics. So if you use a heat map to show that, it will tell you how the higher the correlation, the darker the intersection between the scores of the students you're considering. Okay. We can also have something called violin plots. Violin plots actually combine features of box plots and density plots. They show the distribution of the data across different categories. So, example, a violin plot comparing the distribution of scores in different subjects like math, science, and English can illustrate both the median score and the density of scores, revealing any underlying distributions that may not be obvious in a box plot. So, if you look at this now, so look at the box plot. So you see, for students in maths, right, median score, the median score of students in science is higher than followed by math, followed by English, except that, that the range is wider for English now. Then the fatness of the violin also tells you how well distributed it is. So you have more students doing well in English than compared to the other subjects. That's what these violin plots are actually telling you. So there's so many more things we can actually use. Okay, of course, this is random. Let me generate again and say, okay, so you can see there's a shift because the scores have changed. So you can keep changing like that. So there are all kinds of tools we can use to graphically represent descriptive statistics like that. Okay. So conclusion, graphical representations of descriptive statistics serve as powerful tools for data analysis, making complex data more interpretable. By utilizing these various formats, analysts can effectively communicate insights, identify trends, and facilitate decision making based on data. Just like they say, right? A picture is worth more than 1,000 words. So if you have 1 million data points, just a graphic, a representation like this can just give you an idea of what is happening overall in the data. So each type of graphical representation has its strength and is best suited for specific kinds of data or analysis. So depending on the kind of analysis you are doing, you can find two or more of this useful. So there are some data, the best tool for them is box plot. Some it may be pie charts or bar charts or histogram. So just know, you have to get familiarized with all of these different representation formats and see which one works best for your data set. So mostly if you're working with numerical values, right, heat map and scatter plot and line graphs can be very useful. But if you're working on maybe things that are not, they don't have so many, it's not like they have numerical values. Maybe they're just categorical. Things like bar chart, histogram, and pie chart can work better in those cases. All right. So with use, it will get you get more familiar with these things. Thank you so much for listening always. If you have not subscribed to this channel, be sure to do that because there's so much to learn here. Of course, you want to hit the notification bell so you can always get alerted each time a new video is released. And then don't forget to comment, like, and share. Comment if you want me to teach on a particular topic or you want me to solve a problem. I get to do that. So feel very free. Comment, like, and share so that more people can have access to all these great things to learn. Thank you so much. See you next time. Bye.